Hey everybody, this is Mr. Ainsworth, and we're getting into a big lesson here, which kind of puts everything together here in terms of graphing inequalities and also isolating Y-Intercept method, the work. So this is a great lesson also to review for your exam this week, all right, over linear functions. So get a red pen, get a highlighter, pencil, you name it, get ready. We are going to go over how to graph inequalities that are expressed in standard form. I'm talking right here, standard form. Or you can highlight this right here, okay? Ax plus by is less than or equal to c. All right, or we can switch the inequality any way we like, either less than, greater than, or less than or equal to, or greater than equal to. You got four different inequalities, right? So in fact, let's review that. So we got less than, greater than, we got less than or equal to. Let me write that a little bit better. Less than or equal to. Okay, and then the fourth one, greater than or equal to. Okay, so what we're going to do is we're going to go over the prerequisite skill first. We're going to take a point, okay, x comma y. In this case is negative 3 comma 1. X is negative 3 and 1 is the y value here. And we're going to determine whether or not it's a solution. All right, determine whether or not it's a solution. So what we do is we take this point right here and we substitute it in, right? SUB for short. We do that in any equation or inequality. It doesn't matter what we're given. If you want to test a point, you simply substitute it in. And then see if you have a true or false statement. So let's do the prerequisite skill here first. Let's test if 1 is less than or equal to 3 times negative 3, all right, plus 2. By the way, this is a review. So what you guys should do is pause the video right now, work this out, and then press play when you're done. All right, let me write that down. Pause and play. Especially if you're without me right now. If you're doing this in class with a substitute, or if you're at home, you can pause the video right now, work it out, and press play when you're done. And constantly, work with me here instead of just sitting down and copying, okay? Pause and play. So let's work this out. Is this true, false? I don't know. So simplify the right-hand side. So we got 1 less than or equal to negative 9 plus 2. Negative 9 plus 2 is negative 7. So is 1 less than or equal to negative 7? And of course not, because a positive can't be less than a negative. All right, so this is false. And so what that means is that negative 3 comma 1, the point that we're testing here, is not a solution. That's what false means. If it was a true statement, then I'd say it is a solution. Okay, so you only have two choices here. On the next one is negative 3 times negative 3 plus 2 times 1, y is 1, greater than 2. Is that true or false? I don't know. Well, we get 9 plus 2 is greater than 2. Of course it is. I mean, 11 is greater than 2, right? So here we have a true statement, which means that our test point is a solution. That's what true means. All right, it means that our test point, whatever we're testing, is a solution. So false means it's not a solution. And true, well, that means it is a solution. Okay? Keep that in mind. Okay, so here is 1 equal to negative 3 times the x value of negative 3, all right, minus 8. Well, 1, let's simplify. Negative 3 times negative 3 is 9. 9 minus 8 is 1. So 1 is equal to 1. Of course it is. All right, so that's a true statement. So that tells me that negative 3 comma 1 is a solution. All right, so when you test a point, you substitute it in correctly. Like right here, I substituted in negative 3 in for x, and I substituted in 1. Whoops, not right there. I substituted 1 for y because that was the point that I was testing. Okay? All right. Now let's use this skill in a variety of situations here. And what we want to do is graph an equation in what's called standard form. All right, a times x plus b times y is greater than c in this case, where a is 2 and b is negative 3 and c is 6. All right, and what we're going to do is we're going to isolate y to get it in slope-intercept form. Notice that y is isolated. This is your first basic skill, all right, or your first method is to get this equation from standard form. This is standard form, all right, to, to slope-intercept form. So we want to go from here, basically, all right, to here. All right, so all we do is isolate y. So what we're going to do is we're going to take our equation over here, do our work on the right-hand side, like we always do, all right? And in terms of the steps here, guys, let's do step 1 is always add the opposite of the x term. Add the opposite of the x term, the term involving x. So if you see positive 2x, well, look in red, you're going to add a negative 2x. Okay, if you go back in prior lessons, I said the same thing. If you want to pull out your notes, be my guest, okay? Bring down the negative 3y. It's being subtracted here, so it's actually negative. That's a negative sign right there. So negative 3y is greater than negative 2x, write the x term first, plus 6 because 6 is positive. Okay, so now step 2. Step 2, divide by the coefficient y. So divide by the coefficient. Get used to that word too. Coefficient of y. Underline that word coefficient. And that right there is sitting right here. It's negative 3. And one of the things I noticed on your last quiz is that most people knew that they had to divide by the coefficient, but you have 3 terms up here. I saw a lot of people divide only 2 out of the 3 terms by the coefficient. So watch closely. Divide by negative 3 here, here, and here. There's 3 terms. So when you divide both sides by negative 3, you have to divide all 3 terms. Okay? All 3 terms. Okay? By the negative 3. What happens? Well, negative 3 divided by negative 3 is 1. 1 times y is y. You got to switch the inequality here because you divide by a negative. So, ooh, look at that, less than. Okay, I'll talk about that here in a minute. These negatives cancel, so you get 2/3 x. 6 divided by negative 3 is negative 2, so minus 2. So you get your slope here and your y-intercept here. So the slope is 2/3 and the y-intercept negative 2 or 0, negative 2. It's called your y-intercept, which you're going to plot first. Okay, now let's review something here and let's highlight something before we do all the graphing here. What you want to do when you divide by a negative, okay, is you want to switch the inequality. So let's put this in red. Switch the inequality, it's called an inequality, not sign, when dividing by a negative, okay, number. This is a key concept right here. So notice how I went from, let me put it in green, from greater than to less than. You got to switch the inequality when you divide by a negative. If I had to divide by a positive 3, I wouldn't have done that, okay? Only when you divide by a negative. So at this point, we graph, okay? So let's draw the boundary line. And right here, I can tell, and we'll do the advanced way, just by looking at this, that it's going to be dotted first of all. Dotted boundary line, BL, all right? And the solutions are below. And solutions are below the boundary line, below boundary line. So I can just tell that right away. This is the advanced method. I don't have to test points all day long. Okay, I can if I want, but I don't need to. All right, because I know that less than or greater than is a dotted line. If it says less than or less than or equal to, it's below the boundary line. So we got to graph the boundary line. So we're going to start plotting at 0, negative 2 on the y-axis. Okay, notice it's the y-axis, the vertical one here. That's why they call it a y-intercept, by the way, not an x-intercept, because it's on the y-axis. Okay. All right, and then you got to go up to right 3. Notice the direction, all right, from the y-intercept. So put your pencil at the negative 2 at the y-intercept here and go count 2 up. 1, 2. Look at the red dots. Count right 3. 1, 2, 3. Okay, repeat it. Up to 1, 2, right 3. 1, 2, 3. All right. If you want to reverse it, you go down 2, left 3. 1, 2, 1, 2, 3 to the left. All right, you take your straight edge out and draw a dotted line. Or do what I do, is I just draw the line, and then I get my eraser. All right, and you make it dotted, okay? Because the solutions are not on the boundary line. Solutions are not on the boundary line. Why? Because it's strictly less than right here, not less than or equal to. Okay, so it's dotted. So the question is, where are they, above or below? Well, it's less than, so it's below. So you can do this. You can say, okay, solutions are below, or you can take out your highlighter and highlight below the boundary line. See, this is where the solution region is. So the solution region. Okay? And that, my friends, is how it's done, step by step. All right, so now it's your turn to try it. So I want you to pause the video here and give number 2 a shot, and then when you're ready, press play. All right. And once again, if you're in class with a sub, just press pause, let the class work on it, and then press play when you're done. Or if you're on your own, be honest with yourself, have a little integrity here, and press pause right now and go for it. Okay, I'm going to assume you're back, and so I'm going to perform all the steps, assuming that you already went through it. So we have 3x plus 4y is greater than or equal to 8. Subtract 3x. Okay, we add the opposite of the x term, right? Opposite of a positive 3x is a negative 3x. And we get 4y, we'll just bring that down, right? Is greater than or equal to negative 3x plus 8. Divide all terms by 4. And we get y is greater than or equal to. You don't switch the inequality here because you divided by a positive and not a negative, so this rule doesn't apply. Is greater than or equal to negative 3/4 x plus 2. All right, you simplify. So my slope is negative 3/4. You got to go down 3, right 4, with a y-intercept of 2, or 0, 2. Okay, so already I can see right here, okay, that it's going to be a solid boundary line. All right, and the solutions are above because of the greater than symbol. Okay, and solutions, okay, are above the boundary line. So when I graph this, I already have a vision in my head. So I start at 0, 2. I go up 3, right 4. 1, 2, 3, 1, 2, 3, 4. Reversing, 1, 2, 3 below, 1, 2, 3, 4 to the left. Okay, keep it solid this time because it's greater than or equal to. All right, and they're above. Okay, so the solutions are up here. So let's shade above. Okay, there's your solution region on the line and above. Okay, so here solutions are on, okay, boundary line. Why? Because it's solid. Dotted means that they are not on the boundary line. Solid means they are. So remember that, okay? So anytime you see greater than or equal to or less than or equal to, it's going to be solid boundary line. And that is how the first method is done. So what we need to do is learn another way to do things, okay? And it is called the Intercept Method, okay? Which you've seen before in prior lessons involving zeros, okay? The Intercept Method, or the method of using zeros. Using zeros. Okay, so what we're going to do is we're going to find the x-intercept by letting y equals 0 and solve for x. We're going to get the x-intercept first, plot it, and then find the y-intercept similar way. We let x equals 0 and solve for y. We'll graph the boundary line, and then we'll do a test point. We'll test the origin, see where we shade, because it's not going to be in slope-intercept form. Okay, now right away I can see, though, I can see greater than here. I know that we have a dotted boundary line right off the bat. All right, but in this form right here, you can't tell whether it's above or below, and that's why you have to test the origin, which is 0, 0. We'll do that later. Okay, that tells you where the solutions are. All right, so let's do the x-intercept method here, or x-intercept first. We're going to let y equal 0. So negative 2x plus 3 times 0 greater than 9. Excuse me, we're going to use the boundary line for this. So I'm going to switch it to an equal sign. Okay, so let me note that. Use the boundary line. Use the boundary line for this. So switch it from a greater than to an equal sign when you find the intercepts. Otherwise, you won't be able to find them, guys, okay? So, well, 3 times 0 is 0. That's easy. So you have negative 2x equals 9 equals 9. Switch it to an equal sign for the boundary line. Always do that. Divide by negative 2. And you have x is equal to negative 4.5. Okay? So you have negative 4.5, comma 0. Remember, look at this. Y is 0. Okay? So there's negative 4.5 comma 0. So let's plot it. So negative 4.5 comma 0 is right here. There's your x-intercept. The y-intercept is found in a similar way, but we let x equal 0. So negative 2 times 0 plus 3 times y is, when is that equal to 9? Well, that's 0. So 3y equals 9. So 3 times 3 is 9, right? So y equals 3. So since, x equals 0, this is 0 comma 3. This is called the y-intercept. Now 0 comma 3 is up 3. It's right here. So that's your y-intercept. On the y-axis, right? This is the y-axis and this is the x-axis. Okay, and now you graph them. You graph the boundary line. I'm going to draw the line and then make it dotted here in a minute. Oh, not totally correct here. Let me get it better here. Okay, that's a little bit better. All right, and let me make it dotted because it's strictly greater than, which means the boundary line is dotted for sure. I just don't know where the solutions are because it's not in slope-intercept form. Okay, so we got to figure out where they are, right? So that's why I said test the origin, which is right here. Test the origin. If that's a solution, we shade down. If it's not a solution, we shade up. All right, the solution region is above. So we got to check it out, okay? You're going to have to put a 0 here and a 0 here. It's easy. All right, so negative 2 times 0 plus 3 times 0. Is that greater than 9? Is 0 greater than 9? I mean, both these are 0, right? And 0 is not greater than 9. This is false. Okay, it's false, which tells me that 0 comma 0 is not a solution. Okay, so that's not a solution, so they're not below. All right, solutions are above. That's what it tells me. Solutions are above boundary line. So I'm going to shade up here. So let's get your highlighter out and let's do that. Ooh, that's not good. Not below it, above it. Oh, much better there. Okay, there's the solution region right there. And for some people, this method here is faster than solving for y. So some people like this compared to the other one, okay? All right, but regardless, you guys need to get good, all right? So what I want you to do right now is pause the video and press play when you're ready. So if you're with a sub, go ahead and press pause right now and work it through. When you're ready, press play. Or if you're home, do the same thing. Have some integrity and do that instead of just sitting there in front of the computer and copying. All right, press pause. Okay, I'm going to assume you're back now. So here we're going to take a look at the boundary line here, which is 2y minus 3x equals 2, and we're going to use it. So here we go. We're going to find the x-intercept. So 2 times 0, put a 0 in for y, minus 3 times x, that's equal to 2. So we get negative 3x is equal to 2. Divide both sides by negative 3. You get x is equal to negative 2/3. So my x-intercept is negative 2/3, comma 0. All right, why? Because y equals 0. Look at that. Over here we have let x equals 0. So 2y minus 3 times 0 is equal to 2. So 2y equals to 2. That means y equals 1. So in this case, since x is 0 here, we have 0 comma 1. So let's plot these points. Okay, and already I can tell we have a solid boundary line too, by the way. That's the only thing I can tell. I can't tell where the solutions are above below. I got to test the origin, which I will do in a minute. Let me graph the intercepts. So 0, 1 on the y-axis, negative 2/3 comma 0 is right here. On the x-axis here. Okay, So graph those. Let me grab a line tool. Okay, right in there somewhere. Okay, it's solid. Solid solutions are on the line. Solutions are on the boundary line. That's what that means. Questions are they below or above? So let's test it. So is 2 times 0 minus 3 times 0 greater than or equal to 2? Okay, I test it, all right, in the original inequality. You always test in the original inequality. So 0 minus 0, is that greater than or equal to 2? And of course 0 is not greater than or equal to 2, so that's false. Now here's the origin right here. It's below it, right? So 0 comma 0 is not a solution. So that tells me that the solutions are above the boundary line, that is. Okay, so they're up here. So what we do is we take out our highlighter and we shade up here. Okay, and that's how the game is played. All right. All right, let's do some little bit more practice here. Okay, you try this one. Pause the video and try it again. Okay, I'm going to assume you're done. So let's use the boundary line. Let's just write it down. So 3x minus y equals 2. Just switch it to an equal sign. Easy. All right, so let's y equals 0, right? That's what you do first to solve for x. So 3x minus 0 equals 2. That gives you 3x equals 2. Divide by 3, right? Divide by 3, and you get x is equal to 2/3. Okay, just checking something. Okay, so you have 2/3 comma 0. Now we want to solve for the y-intercept, so we let x equal 0. So we have 3 times 0 minus y equals 2. Okay, 2. And so that's 0, so you get negative y equals 2. You can either multiply or divide by a negative. Y has to be negative 2. The opposite of negative 2 is 2, right? So we have 0 comma negative 2. So let's plot 0 negative 2 on the y-axis, 2/3 comma 0 on the right here on the x-axis. See, this is the x-axis and this is the y-axis. Okay, so I have an x-intercept here and a y-intercept here. Now I just have to test the origin, and I test it in the original inequality. Okay, so 3 times 0 minus 0, is that greater than or equal to 2? Well, that's 0, and 0 minus 0 is 0. 0 greater than or equal to 2. No, this is false. All right, so 0, 0 is not a solution. Is not a solution. Oh, let me draw my line. I got a little crazy here. So let's draw the line first. Okay, there we go. Right through there, something like that. All right, 0, 0 is right here. But it's not a solution. So solutions aren't above it. They're below it. They're on the opposite side, okay? And so you have to graph this way. There's your solution region. All up through here. Okay? Get a little crazy with a highlighter. Have fun. And that's how the game is played. The only thing you need to do is get good. So that's why I said over here, you have 2 more to do. All right. And this is, you get to pick your own method here. Okay? So pause the video now. Pause and play. All right, when you're done. Okay, pause the video. Okay, I'm going to assume you're done. So I'm just going to isolate x. That's what I'm going to do. I'm going to get 4y is greater than or equal to negative x plus 3. I'm going to divide all 3 terms by 4. And I get y is greater than or equal to. Note, don't change the inequality there. I divided by a positive. Negative 1/4. I'm going to pull out the slope. So negative 1/4 x plus 3/4. Okay. So here's the slope and here's the y-intercept. So y-intercept of 3/4, right about there. Okay, it's less than 1, right? So slope is negative 1/4, which down 1, right 4. Y-intercept is 3/4 or 0 comma 3/4. There's your y-intercept. Okay, and now down 1. Okay, put your pencil at -3 or +3/4. Go down 1. Okay, right 4. 1, 2, 3, 4. Okay, or reverse it. Up 1, left 4. 1, 2, 3, 4. Right here. All right, and then you just graph your line. No, right there. All right. Now, from what I see here, I'm looking right here. I can see that the boundary line, okay, boundary line is solid because the equal to part and solutions are above. So solid and above basically. Okay, so I go up. Solution reading is up here. Okay, that's how it's done, my friends. Okay, now you try the last one. Okay, pause the video. Okay, I hope you're done. So add x. I'm going to isolate y again because it's an easy one. Y is less than x plus 1. Well, I can see that the slope is 1, and I can see that the y-intercept is 1. Now, the slope of 1 means 1 over 1, so write 1 up 1 from the y-intercept, okay, which happens to be 0, 1. So we start here, and we go up 1, right 1, up 1, right 1, up 1, right 1. Reverse it, you go down 1, left 1, down 1, left 1. Okay, and you draw your line. You get crazy, okay? And I know it's dotted, okay? I know it's dotted. Just by looking right here, okay, let me highlight this. Just by looking at that, I can see that the boundary line, okay, is dotted, first of all, and it's going to be below. So dotted and below. The solutions are below the boundary line. So I got to make it dotted. So let me get my eraser, and we make it dotted. Okay, and they're below. So you can do this. You can draw arrows below, or you can get out your highlighter, one of the two. It depends on what tools you have. Or you can use your side of your pencil, right? Because that will work too. Okay, this is the solution region here. All these points in here, there's an infinite number of them. They're all solutions. Okay, all of them. Okay, you can pick any point in here and test it, and it will be a solution to the original inequality. All right, and I also included a little summary right here, so you can take a look at this and read through this because it's basically a summary of everything I said. All right. Okay, and like I said before in many of my videos here, you can pause and play rewind. Listen to a little bit more. Go back and listen to the Intercept method before you do your homework. Use it as a review tool. Do anything you like. It's a video, so use the technology effectively. And I'll see you in my next lesson. This is Mr. Ainsworth. I'm out of here. Bye-bye.